Assalamualaikum warahmatullahi wabarakatuh. We from 3D want to present about MEMS. Hi, Muhammad Ashraf Zahar with four members: Muhammad Azri Nazrul, Arif Akbar, Ahmad Daniel, and Fitriatul Akmal.
Part 1 Introduction. This report deals with the emerging field of microelectromechanical system, or MEMS. MEMS is a process technology used to create tiny integrated device or system that combine with mechanical and electrical component. They are fabricated using integrated circuit IC batch processing technique and can range in size from a few micrometers to millimeters. These device or system have the ability to sense, control, and actuate on the micro scale and generate effect on the macro scale. The interdisciplinary nature of MEMS utilize design, engineering, and manufacturing expertise from a wide and diverse range of technical areas, including the integrated circuit fabrication technology, mechanical engineering, material science, electrical engineering, chemistry, and chemical engineering, as well as fluid engineering, optic, instrumentation, and packaging. The complexity of MEMS is also shown in the extensive range of market and application that incorporate MEMS device. MEMS can be found in system ranging across automotive, medical, electronic, communication, and defense application. Current MEMS devices include accelerometer for airbag sensor, inkjet, printer head, computer disk drive, read write head, projection display chips, blood pressure sensor, optical switches, microvalve, biosensor, and many other products that are manufactured and shipped in high commercial volume. MEMS has been identified as one of the most promising technology for 21st century and has the potential to revolutionize both industrial and consumer product by combining silicon-based microelectronics with micromachining technology. Its technique and microsystem-based device have the potential to dramatically affect of all our life and the way we live.
Part 2, background history. Okay, Nathanson invented the first MEMS device, a tuner for microelectronic radios, in 1965 while working as engineer at Westinghouse Research Labs in Pittsburgh. While developing similar device, Nathanson pioneered a method of batch fabrication in which layer of insulators and metal on silicon wafer are shaped and undercut through the use of mask and sacrificial layer. The process would become a mainstay of MEMS manufacturing. Nathanson was granted a patent in 1973 for the use of millions of microscopically small moving mirrors to create a video display of the type or now of the now of the type now found in digital projectors. Later in his career, he was involved in the development of monolithic microwave integrated circuit in gallium arsenide for airborne radar application, concept for atomic clock, integrate circuit on coil, curve, substrate, and electronic system cooling ideas. He held more than 15 patents in the field of solid-state electronics. Now I pass to Azrin.
In 1917, first silicon accelerometer demonstrated. In 17, in 1979, first micro machine inject nozzle. Early 1980, first experiment in surface micro machine silicon. Late 1980, micromachining leveraged microelectronics industry and widespread experimentation and documentation increased public interest. 1982, disposable blood pressure transducer LIGA process and silicon as a mechanical material instrumental paper to entice the scientific community. Reference for material properties and acting data for silicon. 1988, first MEMS conference. At 1990, method of micromachining aimed toward improving sensor. 1992, MCNC start the multi-user MEMS process MUMPS, sponsored by Defense Advanced Research Project Agency (DARPA), and first micro machine Hinge. 1993, first surface micro machine accelerometer sold analog device ADXL15. In 1984, deep reactive ion etching is patented. 1995, bioMEMS rapidly developed. In 2000, MEMS optical networking component become big business.
Okay, thank you, Azrin. Okay, next is application. MEMS can be slide. MEMS can be found in system. MEMS can be found in system ranging across automotive, medical, electronical, communication, semiconductor, defense, aerospace, and more. Some examples of current MEMS devices include accelerometers for airbag sensors, inkjet printer heads, computer disk drive heads, projection display chips, blood pressure sensors, optical switches, microvalves, biosensors, and many other products that are all manufactured in high commercial volumes. Okay, next there are 4 applications. First is RF application, such as radar, as an example for industrial, automotive, care management, defense, and securities, or communication, base station, cell phone components, or connectivity. It could be Bluetooth, Wi-Fi, or Zigbee for RF power, such as radar, broadcasting, cooking, and lighting. For MEMS sensor, Philips technology platform for micro and nanotechnologies is very suitable for the manufacturing of various kinds of MEMS devices and sensors. Philips Circumflex Sensors platform is a basis for state-of-the-art sensors for measuring temperature or pressure. Next is microfluidic devices. Microelectromechanical system or MEMS are mechanical and electrical structures in silicon wafers using photolithography, etching and deposition processes to create structures for microfluidics such as wells, nozzles, jets, and flannels. And lastly is capacitive micromachine ultrasonic transducers, or short form as a CMUT. CMUT technology is capable of operating in a wide range of conditions such as temperature -40 Celsius up to 200 Celsius or up to 250 Celsius with application-specific design, or pressure up to 10 bar, and abrasion resistance, protective stacks available for various applications, scratch and impact resistance. Next, I pass to Ammar.
Part 4 Future Trend. There have been phenomenal and unparalleled technology and system development in the 20th century. For the most part, These developments are discrete in nature's semiconductors progressing in integration and system progressing to meet their discrete marketplace needs such as computing, telecommunication, telecommunication and consumer function. The 21st century, however, will be characterized by broad integration of technologies such as microelectronics, photonics, RF and wireless, and MEMS, but also by integration of systems as illustrated in figure below that show the integration of computer, consumer, and telecommunication products all in one. The I/O in figure below for automotive, handheld, cost performance, and high performance represent the single largest part of system packaging. Together, they are capable of unimaginable. A digital performance A digital performance of the order of 10 GHz digital computer clock speed, BRF performance of the order of 100 GHz RF or wireless speed, optical performance of the order of 10 terabit per second, optical bandwidth in miniaturized system made possible by microsystem technologies described in this chapter. That's all from our group 3D. Thank you.